rectangular hyperbola. Okay, yeah. There's a intensity, there's a density. Two rho naught. Okay, 2 moles of diatomic gas undergo cyclic process in intensity versus a letter. Again, you may think volume, that is, huh? Density graph. Huh? Path 31 is a part of hyperbola. Is a part of rectangular hyperbola. Find efficiency of gas in one full cycle. Okay, you have everything in question. Okay, I think now the primary thing is we have to identify the what is each path. It's an intensity versus density. Earlier we plotted equivalent graphs. Now directly we'll bring the euro graph. What is the path 1, 2? He has not given density. Anybody? What shall I write density? Density of gas. 5 rho naught because rectangular hyperbola. It should be 5 rho naught, no? Okay, now what is 1, 2? Density constant. So it should be, and intensity increases. So density constant means volume constant. Intensity increases means isochoric heating. So the gas is absorbing heat. There's a question. Let me go for equivalent one. Let's work out everything in this graph. Okay, what is the process 1, 2? It's a isochoric heating. 2, 3, anybody? Intensity constant. Isothermal expansion, because density decreases means volume increases. So isothermal expansion. So heat is absorbed. Directly go back to the basic formulas. Okay, isothermal expansion. And then what about 3, 1? Rectangular hyperbola. Euro graph rectangular hyperbola. Anybody wants to reply?
Isobaric, sir.
Isobaric process as in fact, and what's happening here? Intensity decreasing. So isobaric cooling it is. It is rejected. So what is Q31? Okay, no. Okay, now shall we go for area under Euro graph work done? I think that's the best simple formula. Anybody wants to support me? Area under Euro graph. Sir, work done. Finish or? Or no, no, sir, cannot be. Anybody wants to? Only in PV graph, area under curve in PV diagram is worked done. In another graph, it's not there. Better to calculate. So I'm asking efficiency. Shall we calculate work done in each path, then Q positive, or better go for Q positive, Q negative? Better to go for Q positive, Q negative. No, you'll save time. So what is Q positive? We'll calculate. I'll begin here. Q positive. Okay, where all it is absorbed. Q12 plus Q23. What is Q12? Isochoric heating. What is Q12? Change in energy. U2 minus U1. In isothermal process, N R temperature of gas at 2 log of volume of gas at 3 by volume of gas at 2. I think everyone is able to recollect the formula. nRT log final volume by initial volume. We don't know temperature, we don't know volume. Let's see what we can do it. Okay, after this, what is U2? As we know, intermediate gas, phi U naught. U1, 2 U naught, very simple. What about the interchange? So what is this phi U naught? You can write it as this phi U naught. You can also write it as nRT2 gamma minus 1. Interchange definition, U equal to NCV delta T or nRT gamma minus 1. So nRT2, we can write this much here. nRT2, so gamma minus 1 phi U naught. Log of, we don't know volumes, what to do. How density and volumes are related, inversely proportional. Because mass of a gas will be constant, no, density equal to mass by volume. Mass equal to density of gas into volume of gas should be equal to rho 3 V3. Let's take that one. What is the density of gas at this will be? Phi rho naught V2. This should be equal to rho 3 is 2 rho naught V3. Tell me like what is V3 by V2? Should be equal to 5 by 2. V3 by V2 is needed, no? Okay, 5 by 2 equal to V3 by V2. I'll substitute all the values. So 3 U naught. Gamma for diatomic gas, anybody gamma? 7 by 5. Okay, log of this will be 5 by 2. I think we can further simplify 3 U naught. So this will be 2 U naught. Okay, directly we got Q positive UC. Next Q negative. Isobaric process, what is Q? N Cp delta T. What is delta T? T1 minus T3. Or if you remember formula Q in terms of gamma, we had some formulas. Okay, I'll write it in order. Okay, number of moles. Okay, let it be as it is. Cp for this one, phi r by 2. Keep it here. So T1 minus T3.
Sir, 7R by 2. Diatomic gas.
7R. Huh? Yeah, 7R by 2, I wrote it. So number of moles, what we know. So, but we don't know T1. Again, the same set of formula. NR T1 should be equal to gamma 1 minus 1 into 2 U naught. NR T3 should be equal to gamma minus 1 into 5 U naught. 7 by 2, let me keep outside. So 7 by 2 nRT1 minus nRT. What is 2 U naught? It should be equal to nR okay, this is also equal to what? nR T3 because temperature will be constant, no? Okay, take help of formula. nRT1, what we can write it as? Gamma minus 1 to U naught. Gamma minus 1 phi U naught. Gamma minus 1 will come outside. 7,321 negative sign, no? Gamma for 7 by 5, no? 7 by 5, 2 by 5, 21. So minus. Okay, there's a Q negative. I got Q positive, Q negative. So what is the efficiency now? Q positive minus Q negative by Q positive. So we'll get the required answer. Okay, no, if they give intent, it's very good. No, we need to go for calculating temperature directly for isobaric process. What is Q? In terms of gamma delta U, you can write it. Is that formula okay? Gamma delta U by gamma minus 1. That is the formula. Isobaric process, how Q and delta U are related. NR delta T, I think gamma delta U. Am I right? Isobaric process, Q equal to gamma delta U. Directly you can substitute that formula, you'll get the same answer. Okay, let's go for the efficiency. No. So what is the efficiency? No. Mod, we have to take why mod? Okay, efficiency cannot be greater than 1. No. Okay, can you work out? So just only substituting and solving, we'll get the required answer. Okay, how to plot equivalent graphs? Next part of the discussion is plotting equivalent graphs. What are equivalent graphs? PV graph, PT graph, and VT graph. But sir, we don't know pressure, volume, temperature. I'm just asking rough shape. May not be exact. Next part is equivalent graphs. Well, okay, let's bring that. This one. Okay, yeah, we brought it. Okay, now PV graph, VT graph, and PT graph. All three are needed. Okay, there's a pressure versus. If you want any other graph, you go for it. Huh? No, pressure versus volume. Pressure versus temperature. Volume versus temperature. Now, what is 1, 2? Isochoric heating. So vertical line. There should be a vertical line. So where you are going to draw a vertical line? I myself, I'm not sure. I'm making a guess. So I myself, I'm not very sure that I'm right or wrong. Okay, let me take this. Not vertical. Huh? Yeah. No. Okay. Yeah. This is 1, 2. Then 2, 3 is what? Isothermal. Isothermal expansion it is. I'll bring it. Okay, isothermal expansion. So isothermal expansion, how it will be? So it will be curved. Then afterwards, 3, 1, isobaric cooling. Hope able to understand. So what is 1? The 1 will start from here. 2 and this is 3. Got the idea? No, PT graph. Isocoric process in PT graph. Isocoric eating in PT graph. Straight line passing through origin. So you have some idea like this. Okay, first you draw that straight line. Okay, no. This is 1, 2. Then afterwards, 2, 3 is what? Isothermal expansion. So in isothermal expansion, what happens? Pressure will decrease, temperature constant, so vertical line. Then afterwards, 3, 1, 3, 1, isobaric cooling. So how the graph curve will be? This is 1, 2, 3. Student has to think here. There's no magic formula. So shall I tell you students what they want? They just want to draw a curve. They just want to draw a curve. How it is possible? So first you identify path no 1, 2, 1, 2, 2, 3. Okay, you may not get exact shape. You can redraw it. Okay, now volume versus temperature graph. Isocoric heating, it should be a horizontal line. So shall I draw it here or here? Draw anywhere. Later on we'll see. So shall I draw it above or below? Draw it anywhere, some horizontal line. That's all, no? We need one horizontal line. Okay, this is isocoric heating. Then isothermal expansion. So it has to come like this, no? So therefore you can shift it down. So then later on, see, like I myself, your teacher also could not just assume somewhere it should be like this. Then isothermal expansion, temperature constant, volume will increase. Then afterwards, what we have? Isobaric cooling, straight line passing through origin. One, two, this is 3. You have to put effort. There's no other way. No need to sleep today. Today night, no. You try, put effort. What is there? One day if you don't sleep, what will happen? Or sleep for 2, 3 hours. Struggle it, put effort. Nothing wrong. Huh? Because anyway, in future, you're not going to have a good sleep. Practice now only that. Not having sleep, how the life will be. Okay, this is I'm asking now. Okay, plot for this. Density versus pressure. You have to try. Yeah, I'll not help you anything. I don't know also, better to say. You have to put effort. Okay, got this one. Efficiency, equivalent graph, whatever let them ask, you should be in a better position. You have to ask questions, sir, like why you are not discussing adiabatic process? This is the best question. So means adiabatic process comes, we can't draw equivalent graphs. Yes, we can draw what is there. Even for with adiabatic process also, we can plot equivalent graphs. Okay, let me give one problem on adiabatic process. These are the volumes. We have to give the lines, no? Carefully make observation, all these things. Okay, these are the horizontal lines. Yeah. It's a PV diagram only. Don't get scared any other thing. Pressure P naught by 32. This is P naught, V naught, 2 V naught, 8 V naught, 16 V naught. A, B, C, D. A, B, and C, D are adiabatic process, and you know, so there's a pressure. DA and CB are isobaric process. So let me write path. So I want temperature versus volume graph. Other graphs you should try. Okay, I'll show only one because I had to touch all other different cases. No. Okay, temperature versus volume graph. So what is the question that is asked? Plot temperature versus volume graph. Yeah. What is in temperature versus volume? Isobaric process, how it will be? Isobaric process in temperature versus volume. Straight line passing through origin, will agree? It should be a straight line passing through origin. So I'll two straight line, two processes are there. Let me put like this here. So what is dA should be? As the gas moves from D to A, what will happen to temperature of gas? Will increase, no? So therefore the dA should come somewhere here. Next, what about BC? Adiabatic cooling. So it should be straight line passing through in temp. Cooling means temperature should decrease. So therefore it is one more like this here. Oh, no, where is the volume of gas? So what is the path? This is the, I think will indicate no. The next point is very important. This is D. Volume of gas A. Okay, A. This is B. B is IH volume, no? Okay, I'll extend the graph. Okay, D, A, the volume of, and C should be more, no? C should be more than that one. Sorry. No, let me come from the beginning. Yeah. Okay, there's a point A if I take it. The volume of, okay, this will be A. Next afterwards, what happens? C will come. So the C should somewhere be here. From here, the curve should be brought. If not here, okay, yeah, this is, yeah. B should be here and this is C. Okay, no, I think we are in better position. I indicated the path. What is this? This is DA. And this is BC. Okay, tell me like, what about the adiabatic process? How to plot in temperature versus volume graph? Horizontal line, isothermal it will become. It should be a curved one. So therefore the path will be It should be like this. If you want to check with your mathematics later on, now similarly, what you should do, plot pressure versus temperature, and intensity versus the density also. Try all these graphs, no problem. And I'll just indicate the axis. You have to fill up the curves, suitable curves. Plot temperature versus volume graph. Afterwards, intensity versus density, pressure versus temperature. There's a pressure, temperature, intensity, density. TV graph, Euro graph, PT graph. Please try this. Okay, let me go for the next one.